So welcome to another segment as we now look at some practice questions on transformers. So these are some sample questions that have come before in the exam. The first one there says that a transformer is used to step a voltage of 230 volts down to 10 volts. So you're stepping from 230 volts to 10. So this is a step down transformer. The secondary core has 60 turns. Calculate the number of turns in the primary coil. So according to that one, if we look at the solution, the information, the voltage in the primary is equal to 230 volts, and that is being stepped down. The voltage in the secondary is simply 10 volts. Then they have told you that the number of turns in the secondary, so the number of turns in the secondary is equal to 60, but they want you to find the number of turns in the primary. If you remember the formula that I had given you, let me just remind you on that one. I did say that number of turns in the primary over number of turns secondary is equal to voltage primary voltage secondary is equal to current secondary and current primary. So if you look at the information we have, we can compare number of turns to the voltage. So therefore, I'm going to say the number of turns primary over the number of turns secondary should be equal to the voltage primary over the voltage secondary. So we just need to replace now in this formula there. What's the number of turns in the primary? That is what we want to find for. The number of turns in the secondary is simply 60, which is equal to, do we know the voltage in the primary? It is 230 volts over the voltage in the secondary, that is simply 10 volts. So from there you can cross multiply. It will be NP multiplied by 10 is equal to 60 multiplied by 230. To find NP, I'll divide 10. What I do this side, I'll do it the other side. Therefore, my NP will be equal to, if you work out that, this and that will cancel. If you multiply on your calculator 230 multiplied by 6, it is going to give you a 1380. So our answer is going to be NP is equal to 1380. Just add the word tens. So that those are the number of tens that should be on the primary in order for the number of tens in the secondary to be 60. So the final answer is 1380 tens. So that is the final answer that you're going to have. So it's very simple. It's not complicated. You need to remember that formula that you can apply there. Of course, I also did mention that if you still remember that we did mention that the power input should be equal to the power output, where we said voltage primary, current primary is equal to voltage secondary and current secondary. So let's look at the second one there. It simply says that the diagram shows a 12 volt 3 amp lamp being operated by a transformer using a 240 volt supply. So this is what you've been given. So if the transformer is 100%, so that should have been 100% efficient. So that should be 100. If the transformer is 100% efficient, what is the current flowing? What current will flow from the supply? So the supply is simply the primary core. So what have they given us? We know the voltage primary is equal to 240 volts, but we do not know the current in the primary. But if you notice, you know the voltage in the secondary, which they have given you, is 12 volts, and the current in the secondary is simply 3 amps. So we can apply this one there. Power input should be equal to power output. Therefore, Vp times Ip should be equal to Vs times Is. That's what we mean there. So therefore, the voltage in the primary, we know that is 240 volts times the current in the primary. We don't know. So that's what we want to find for, which should be equal to the voltage in the secondary is 12 volts times the current in the secondary, which is 3 amps. So this times that will give us 240. Ip is equal to 12 times 3 will give us a 36. To find IP, I'll divide 240. What I do this side, I'll do it the other side. So therefore, from here, I can therefore say that IP is equal to, if you divide 36 divided by 240, that is going to give me a 0.15 amps. So meaning the current that will pass through the primary core is simply 0.15. So that is what is going to happen there. All right. Sorry for that disturbance. Let's move on to another typical question that you're going to be finding in the exam. And this is a question that I've actually projected already, and that is our question number 3 there. Please pay attention with this question as well. So it says the figure below represents a transformer with a primary core of 400. So if you notice, the primary core has got 400 turns and the secondary core 200. So this side you have 400 and this side you have 200 turns. The voltage in the primary is 240 volt. So it says what type of a transformer is shown above. So from this, they will ask you to identify the type of transformer that is actually shown. So we can identify the type of a transformer that is actually shown in the diagram there just by looking at the number of turns that they have given you. From looking at the number of turns, I know that this is a step down transformer. Why? You have more number of turns in the primary than in this. So it's like you are moving from high to low, so you are stepping down. So therefore, the type of a transformer there is a step down transformer. Now the question says there that we justify our answer. So how can I justify? I can say because there are more turns on the primary. So there are more turns on the primary than secondary. That's what we mean. In other words, the number of turns on the primary is greater than the number of turns on the secondary. So that is why we are saying that this is simply a step down transformer. So you can relate it to that. Right, so that's the A part. Let's move on to the B part. So the B part there says I need to create some more space so that you are able to see. So it says the primary core is connected to 240 volt AC, means calculate the secondary voltage. So they want us to calculate the secondary voltage. Allow me just to clean up this section because we have already gotten the concept of what the question is saying. So if you remember the B part, the number of turns on the primary is equal to 400. The number of turns on the secondary was a 200. The voltage in the primary, they gave us a 240 volt, but they want us to find the voltage in the secondary, which we don't know. So that's what the question, the B part, is basically asking us. Calculate the secondary voltage. All right. So again, we can compare number of turns in the primary over number of turns in the secondary is equal to voltage primary over voltage secondary. Remember that formula? We just need to substitute. The number of turns in the primary, do we know that? Yeah. So the number of turns in the primary is a 400 over the number of turns in the secondary is a 200, which is equal to the voltage in the primary. Yes, it is a 240 volt over the voltage in the secondary. We don't know. That's what we want to find for. So we cross multiply. This times that will give us 400 Vs is equal to, that is going to be equal to 200 multiplied by 240. To find Vs, I'll divide 400. What I do this side, I'll do it the other side. Therefore, our voltage in the secondary will be 200 there is 1, 200 there is a 2, 2 there is 1, 2 into 24 is 12, into 240, that is going to be 120 volts. So therefore, the voltage in the secondary is simply 120 volts. So that is what the question, was asking you to do there. Right, so this is the most important question that you're going to be finding as well, because in most cases in the exam, it will be carrying 4 marks in your ECZ exams. Explain carefully how the transformer works. In other words, they're talking about the working principle of what we are calling as being a transformer. So how can you go about that? So I'll just give you a simple principle, the working principle of a transformer. So normally, the working principle of a transformer, if I can relate it to that, it's very simple. So when an alternating electromotive force is applied in the primary, it will produce changing magnetic fields in the primary core. So these magnetic fields that will be produced in the primary core will be connected to the secondary core via the soft ion core, and hence they will be linked to the secondary core. So as they continue to alternate in the secondary core, they produce an alternating electromotive force in the secondary core. That is through mutual induction. Please watch out for my other videos so that you can understand also on mutual induction in case you didn't. So I can give you concept there, that I can give you the working principle of a transformer. So the working principle, how a transformer works. So I can put up some few points, so we can maybe say when an alternating electromotive force, which you can call as being your EMF in short, is applied, so we can say is applied to the primary coil, a changing magnetic field is produced. Then we can say the soft ion core links this field to the secondary coil. So this alternating, field, that's magnetic field, remember, produces an alternating means it's changing, an alternating electromotive force in the secondary coil through mutual induction. So that is what you need to remember. So through mutual induction. So that is what is going to happen. So this is the working principle of a transformer, how a transformer works. So you need to remember this. Please go through, because it carries 4 marks in the exam when they ask you to carefully explain how a transformer works. Or sometimes the question can say, explain how a voltage or electromotive force is produced in the secondary core. The question is simply asking you about the working principle of a transformer. So that is what you need to remember. Let's move on to, that should be D and this is E. The D part there is simply saying, why is soft ion used? Why is soft ion used for the core instead of steel? So for the core of a transformer, why do we use soft ion instead of steel? Well, there are so many reasons why soft ion is actually used instead of steel. Maybe let me just give you 2. We can simply say, 1, soft ion, can easily be magnetized. So it can easily be magnetized and demagnetized. So that is one reason why we use soft ion instead of steel, because soft ion can easily be magnetized and it can easily be demagnetized. 2, you can simply say that, soft iron, helps to concentrate. So soft iron helps to concentrate the magnetic, it helps to concentrate the magnetic field lines in the secondary. So these are some of the reasons why we use soft iron instead of what we are calling as being, steel as the core of the magnet, of what we are calling as being the transformer. Right, so please remember that. Let's move on to our last question that we have there. It says, if the current in the primary core is 3 amps, calculate the current in the secondary, in the secondary current. Calculate the secondary current assuming the transformer again is 100% efficient. So the one should to calculate in this case the current in what we are calling as being the secondary. So if you remember, according to the question there, it says that they have told us that if the current in the, I hope I've not mistaken that, if the current in the primary is 3 amps, what is the current in the secondary? So that is what the question is asking you. You can apply a lot of formulas, but the easiest is, remember, we know the voltage in the primary was 240, and we also calculated the voltage in the secondary to be 120 volts. So I can just use and say voltage primary, current primary is equal to voltage secondary and current secondary. That is what I can just apply there, because they're telling me the transformer is 100% efficient, meaning the power input is equal to power output. So the voltage in the primary is 240 times the current in the primary, which is 3 amps, which is equal to the voltage in the secondary 120, and the current in the secondary we don't know. We'll divide 120. What I do this, I do it the other side. So the current in the secondary, will be equal to 120 there 1, 120 there 2. 2 times that will give me 6 amps. Therefore, the current in the secondary is 6 amps. Remember, you could have applied other formulas, you would have still gotten the 6 amps. That is what you need to remember. Now, as I try to conclude, I want to tell you something about transformers. So for transformers, it is possible also to calculate what we are calling as being the efficiency. So I can simply say, maybe I can quickly just give you some few concepts. So I can simply say that we can simply say that efficiency for an ideal transformer. So you can also calculate what we are calling as being the efficiency of a transformer. So it is very much possible for you to calculate the efficiency of a transformer, and they are going to be asking you in the exam to calculate the efficiency for an ideal transformer. That is what we mean. So now, for an ideal transformer, the efficiency of an ideal transformer is that, maybe I can define what exactly efficiency is in terms of a transformer. So we can simply say, maybe the efficiency of a transformer, I can say that the efficiency of a transformer is the ratio. So you can say the ratio of the power output to the power input expressed as a percentage. So this is what we call efficiency of a transformer. So in simple terms, we can simply say that efficiency is equal to what we are calling as being power output over power input, and multiplied by 100%. That is what we mean. But of course, if you remember what we were talking about, efficiency there represented by that symbol would be the power output over power input. Then we just multiply this by 100%. it is possible. But what do you still remember about what we talked about power output? We said power output is simply voltage secondary and current secondary. And power input, we did say it is simply voltage primary and current primary. So you're going to find in this case that, we can replace that and simply say Vs over Is is equal to Vp Ip. So whatever we get, we multiply by 100%. So it is possible that you can use that to calculate the efficiency. Of course, if the transformer is ideal, it simply means that there will be no, the efficiency is going to be 100%. Now, I want you to take note that, when electricity is being transmitted, I want you to take note of that. When electricity is being transmitted, it is actually advantageous to transmit electricity at high voltage and low currents from power stations to the consumers. Why? Because transmitting at a high voltage, we can simply say transmission. I can simply say transmission. Let me say transmission of power at a high voltage and low current actually reduces energy losses. It reduces energy losses in the cable. So that's the reason why we normally transmit power at a very high voltage but at a low current. Why we do that? It is because when you transmit at a high voltage and low current, it actually reduces energy losses in the transformer. So very important, because this question they did ask you in the exam and I wanted to bring it to your attention. Thank you so much. Watch out for some more videos.